Greetings. Let's take a look at single exponential decays and relating half-lives to rate constants. For single exponential decay, we know that A, the concentration at any time, is equal to the initial concentration, the time at zero, e to the minus kt. Now what we notice from this graph is that the amount of time it takes to go from 1 molar to a half is the same as it takes to go from a half a molar to a quarter, or a quarter to an eighth, and that the amount of time it takes a half-life to reduce any concentration to 1/2 is independent of the concentration. And that is the half-life. So the definition of the half-life is at t equal t1/2, A equals A naught over 2. So what we can do is we can substitute this into the above equation. And so we substitute in the half-life criteria. So at 1 half-life, A is equal to A naught over 2, which is equal to A naught E to the minus K T1/2. So does that make sense? So at T1/2, A equals A naught over 2. We simply substitute it into the above equation. Okay. Now we want to solve for k and t, so we need to take the logs, okay? So let's bring everything over to the left side that's not in the log, and we have a naught over 2 divided by a naught is equal to e to the minus k t1/2. Now we can take the natural log of both sides. So we have the natural log of a naught over 2 divided by a naught is equal to the natural log of e to the minus k t1/2, which is equal to minus k t1/2 because the natural log of e is 1. Now we can take the negative of both sides, okay? And remember that when you take the negative of the ln of a over b is equal to the ln of a minus the ln of b. So the negative of ln of a over b is equal to minus the ln of a plus the ln of b, which is equal to the ln of b over a. So when I take the negative of the left-hand side, I have the natural log of a naught over 2, and this is equal to, I take the negative of both sides, k t1/2. Now the a naught over the a naught cancels, and I have the reciprocal of 2 in the denominator. So this becomes the natural log of 2 is equal to k t1/2, and this is equal to 0.693. But this is important, okay? If you know k, or you know t1/2, or if you know t1/2, you know k. Now remember, this is only for first order reactions. You can have the concept of a half-life in any order, but then the amount of time depends on how much you start with. Only for first order reactions do we have a relationship where k t1/2 equals 0.693. So I can have a table of half-lives and know the rate constant, or I can have a table of rate constants and know the half-life. You need to know this relationship.